Let f of x equals x squared minus 4x on the interval 1, 5. Verify that the function satisfies the conditions of the mean value theorem and find the value of c guaranteed by the theorem. Well, it's continuous, it's differentiable, that's fine. So it satisfies the conditions of the mean value theorem. Okay, I could take the derivative anywhere. And I could also know that if I graph that, it's continuous. So again, that meets those theorems. Now, this is the mean value theorem. There exists a c, okay, such that if I take f prime of c, I basically am going to use our old friend f of b minus f of a over b minus a. Remember u? Oh, brings back memories. You would be my a, you would be my b. Okay, so so if I were to do this, f of b would be f of 5, which means I take 5, plug that in, so that's going to be 5 squared minus 4 times 5, which is going to be 25 minus 20, which is going to be 5. Okay, f of a is going to be f of 1, which is going to be 1 squared minus 4 times 1, which is going to be 1 minus 4, which is negative 3. And then I have b minus a. So f prime of c has to be f of b, which is 5, minus f of a, which is negative 3, all over b, which I called 5, minus a, which I called 1. So we got the double negative, meaning you add, so 5 plus 3 is 8, 8 over 4 is 2. So I need an f prime of c that equals 2. So I need an f prime of c that equals 2. Well, f prime of x is going to be 2x minus 4. So f prime of c, I don't know why I wrote it out that way. Can I make that look like an f? Yeah, f prime of c is going to equal 2c minus 4, and that has to equal 2. So I'm focusing on solving this equation right here. Add 4 to both sides, 2c equals 6. Divide by 2, c equals 3, c equals 3. All right, mean value theorem is not as rude as it sounds because of that word. Get it? Like and subscribe. Let f of x equals ln of x on the interval 1 e to the second power. Which value of c satisfies the conclusion of the mean value theorem? Well, the mean value theorem says that exists some c in the interval such that f prime of c is going to be f of b minus f of a over b minus a. Hello, old average rate of change formula. It's been a while. Unless you watched my last video, in which case it's been a minute. We'll call you A, we'll call you B. So f of B is going to be f of e squared. So ln of e squared, ln of e cancels each other out, nice little 2 drops down. Okay? F of A is going to be f of 1, which is ln of 1, which is nerfing. Okay, so f prime of c is going to be f of b, which is 2, minus f of a, which is 0, over b, which is e squared, minus a, which is 1. So I get 2 over e squared minus 1, yuck. Now I'm not done yet, because I need a c that makes this true. So f prime of c means let's find f prime of x and replace the x with c. So f prime of x is going to be the derivative of ln of x, which is 1 over x. So f prime of c is going to be 1 over c, and that so happens to equal 2 over e squared minus 1. Now, what I'm going to do is I'm focusing on this part right here. I'm going to do crisscross applesauce. So 2c equals 1 times e squared minus 1, which is just e squared minus 1. And then divide everything by 2. So c is going to equal e squared minus 1 all over 2, which is none of these options. Well, good job, ChatGPT, for giving me something that I can't even use. But that's how you do it, and that's the correct answer. So we're going to pretend that those weren't even there. I'm not going to redo the video. I'm leaving it, I'm leaving it, I'm leaving it, I'm leaving it, I'm leaving it. Thanks for watching, like, and subscribe. For which of the following reasons does the function f of x equals the absolute value of x fail to satisfy the conditions of the mean value theorem on interval -5, 5? Well, f of x equals the absolute value of x looks like this. And it just so happens that if you're -5 and you're 5, there is a nice sharp turn right there, a nice sharp corner, which means right there at 0, it is not differentiable. Which means in order for the mean value theorem to work, it has to be continuous and also differentiable, and it's not differentiable at 0. So here are our options. The function is not continuous. Oh, but it is continuous. The function is not differentiable. That's correct. The function has a vertical asymptote. That's not true. The function is not defined. That's not true. And the function fails to be differentiable at -5, which is not true because at -5 it's a straight line, so that's not true. So B is our guy.